Okay, DNS exam 4, number 24 is a really interesting question here. They've given you the graph of a function right here. It is I don't want to call it a rational function because these aren't polynomials, but it's a quotient function, both with exponential functions on both the top and the bottom. And they've given you the graph of it here as well. But of course, they didn't give you every piece of information right here because we had these two values right here of a and b, which remember here are not variables, but are arbitrary constants. And we've got to figure out both of those values right there in order to get a sum of a plus b, which is what they're asking for. So this is a really, really interesting style of question right here, and I wish we had a ton of time to get into this. It involves something called a logistic differential equation or exponential growth function, but we're not going to get into that in too great of detail. We're going to try to approach this one and see if we can't figure out the values of these two parts right here. The important thing about this thing here is that they tell us, both through the graph and then also in the text of the problem, that the graph has horizontal asymptotes right here at the line y equals 3 up on top, and then down here at the bottom at the line y equals -5. And the important thing I think about that fact, and something that's worth remembering as we're getting towards the end of the year here in the AP test, is that a function can have two different horizontal asymptotes. One of them applies as the function approaches positive infinity, and the other one applies as the function approaches negative infinity. So I want to talk about each of those in turn here. So the real question here is, everybody, what is the limit here as x approaches positive infinity of this function right here, a e to the x plus b, remembering here now that a and b are just arbitrary constants all over the quantity e to the x plus 1. So, as we look at the graph, it tells us the answer to the question right away. A limit as x approaches infinity means that as x gets bigger and bigger and bigger, what y value is our function approaching? Well, we can see pretty clearly that, like a lot of functions out there, not all of them, we've got a function here that is approaching a y value of our horizontal asymptote at 3, and it looks like it's never quite going to get there. So, because we have a horizontal asymptote at 3 as x is approaching infinity, that means that 3 is the answer to that limit question there. Now that doesn't do us a whole lot of good here for figuring out the values of a and b, but let's talk about that for just a second. If we're considering a limit here as x is approaching positive infinity, that means that x is getting to be a ridiculously large number, 10, 100, 1,000, a million. And as x increases without bound, what happens then is that the relative impact of the constants that are added at the end of the function right here, the b and the 1, basically whittle down to nothing. Those two terms become negligible, meaning their value that they contribute to the function itself is so small as to not really be important. So as these x's are increasing without bound, these two constants right here, even if this was something bigger like a 17 or a 39, they become irrelevant. We can basically just ignore them as x is approaching positive infinity. And then what we're really doing is just looking for the limit of this function right here. Well, with identical factors of e to the x, they would just cancel out. And the only thing we're left with then is the limit as x approaches infinity of a. We know that that limit is 3. So the important takeaway from that, everybody, is that a has to have a value of 3. That's the only way to get this limit as x approaches infinity to be 3. So that is one of the two important things that we needed to find. The second thing that we need to consider now is the other place where a horizontal asymptote can exist. It could be the limit as x approaches negative infinity of the same function, a e to the x plus b all over e to the x plus 1, and we've got to consider what's going on with that limit. Now again, just a quick look at the graph tells us the answer to this limit expression pretty quickly. As x is going towards negative infinity, our y value is decreasing from the origin and approaching, but never quite hitting, a y value of -5. So -5 is the limit here as x approaches negative infinity. But again, let's break this down. In the last limit problem, we were able to cross out the values here of b and 1 because as x was approaching positive infinity, becoming a huge number, the value of these terms increased without bound very, very quickly, And these terms became negligible. That is not the case right here. If we think about what happens to those e to the x terms, x is now approaching negative infinity. And if we think about just a normal e to the x graph, let me cram one of these in here real quick. A normal e to the x graph looks like this. As x approaches negative infinity, our y value for e to the x approaches 0. So what that tells us now is if we're considering this limit here as x is approaching negative infinity, the limit of this term and the limit of this term are both 0. These are the terms that now become negligible as x is approaching negative infinity. And it's these two terms now that are relevant. So one more time, previously, we could ignore these terms right here. They were negligible because x was increasing without bound. But now since x is decreasing without bound, it's these two terms that approach 0, and these ones become important. And the only way then that we can get this limit to work out here is if that value of b divided by 1 would get us negative 5. So b has to be negative 5 in order for that to work out. And now, everybody, we know the values both of a and of b. So the question at hand now was, what is the value of a plus b? The 3 plus the negative 5 is going to get us negative 2, and that tells us, I forgot already right here, that our answer for number 24 is going to be b.